listen-only mode.
Welcome everyone to today's ERRA webinar on CRMs and how they relate to ISO 17025 accreditation outcomes. Before I begin today, I just want to let you know that our webinar will be recorded so that you will be able to download that off our website for any future reference. Also today, I'm flying solo, so I don't have anybody to help me collect questions. So what I'd like you to do is, if you have any questions as the webinar goes on, please type them into the chat box, and I'll collect all that information and I'll post answers to those on our website. Hi, my name is Tom Widera. I am the Inorganic Product Line Manager for ERRA. I'm also in charge of the DMR QA and the whole effluent toxicity and the air and emissions program here at ERRA. Most of you have known me from our webinars in the past. And again, if you have any questions, just type them in the chat box and I will do my best to get them answered for you and get them posted as quickly as I can on the website. Before we begin, just a little bit about ERRA. ERRA is a manufacturer of proficiency testing and certified reference materials for the environmental and the pharmaceutical industry. We were founded back in 1977. We are currently located in the beautiful city of Golden, Colorado, right at the foothills of the Rocky Mountains. ERRA produces PT and QC standards for more than 7,000 laboratories, which are situated in more than 80 countries. ERRA is accredited by the American Association of Laboratory Accreditors, or A2LA. We are an ISO 17043 manufacturing facility. We are accredited to ISO Guide 34, and our laboratory for testing our CRMs and our PT standards is accredited to ISO Guide 17025. ERRA manufactures standards for a number of different industries in the environmental field for wastewater, drinking water, soils, air and emissions, microbiology, radiochemistry. We also make a whole host of custom standards. So if you ever peruse through our catalog and you don't see what you want, we can make you anything you want at any concentration that you're looking for. ERRA is a great source for CRMs to help you with your ISO 17025 accreditation process. So our agenda for today, what are we going to talk about? We're going to talk about the specific technical requirements of ISO Guide 17025, most specifically Section 5. That's your general requirement in which where most of you will gear your efforts towards. Now, if any of you have read through that ISO Guide 17025, you know it's a big, long document, and I'm going to try to summarize that as best as I can for you to give you the requirements that you're really looking for and what you're really looking to accredit to. And then we're going to go and talk about how can CRMs help me meet those requirements. We're going to talk about the basics of a quality control program and the use of CRMs in that quality control program. And by the time we tie everything together, you're going to see that the use of a robust quality control program is going to meet right in with the technical requirements, not only to help you to accredit yourself for the 17025 guide, but also to keep that accreditation current for you. So what are the requirements of ISO Guide 17025? Well, it requires a laboratory to do a number of things: to establish and operate and maintain a quality system which is consistent with ISO Guide 9001. It requires that you be technically competent to operate the test systems for which you're accredited. And it also requires that you're able to generate technically valid results from the test systems for which you are accredited. So let's jump right into Section 5. Now, Section 5 has a whole lot of requirements. What I'd like to do is just go through and summarize all that for you, so that you'll see that even though it looks like there's an awful lot we have to do, by just going through a robust quality control program, especially using CRMs for that, we'll be able to meet so many of these requirements and not only be able to get ourselves accredited, but keep ourselves accredited. So under the personnel section, it says laboratory management shall ensure that the competence of all who operate specific equipment, perform tests and/or calibrations, evaluate results, and sign the test reports and calibration certificates. There's a note in there that says In some technical areas, it may be required that the personnel performing certain tasks hold certification for that. The requirements for personal certification, they might be regulatory or they might be required by a customer who you're doing work for. The management of all the laboratory staff shall formulate the goals with respect to education, training, and skills of the laboratory personnel. The effectiveness of the training actions shall be evaluated. Then we talk about methods and method validation. So the next part of Section 5 states that the laboratory shall use appropriate methods and procedures for all tests and or calibrations within its scope of accreditation. This includes, where appropriate, an estimation of the measurement uncertainty. Any non-standard methods shall be validated appropriately before use. Procedures for non-standard methods should include reference standards and reference materials required, checks that the equipment's working properly, calibration and adjustment of the equipment, uncertainty or procedure for estimating uncertainty. That's for your non-standard methods. Now, the techniques used for the determination of the performance of a method should be one or a combination of calibration using reference standards, inter-laboratory comparisons, most notably PTs, or assessment of the uncertainty of the results. So estimation for the uncertainty of measurement. Testing laboratories shall have and apply procedures for estimating the uncertainty of measurement. When estimating the uncertainty of measurement, all uncertainty components which are of importance shall be taken into account. Our equipment. The equipment used for testing shall be capable of achieving the accuracy required. Before being placed into use, equipment shall be calibrated and checked. Equipment shall be operated by authorized personnel. And it talks about the measurement traceability. Calibrations and measurements made by the laboratory must be traceable to SI units. Certain calibrations and measurements cannot be strictly made in SI units, so confidence in measurements in these cases can be made with the use of certified reference materials provided by a competent supplier. And it goes on to say, participation in a suitable program of interlaboratory comparisons is required where possible. And it discusses reference standards and reference materials. Reference standards shall be calibrated by the body that can provide traceability as described in the previous section. Reference materials shall, where possible, be traceable to SI units of measurement or to certified reference materials. Assuring the quality of our test results. The laboratory shall have quality control procedures for monitoring the validity of tests undertaken. The resulting data shall be recorded so trends are detectable. The monitoring may include the regular use of certified reference materials or participation in proficiency testing programs. So a bunch of you are probably saying at this point, hey Tom, this is a lot of technical jargon in here. What does this all mean to me? In a nutshell, it means two things. It means traceability and it means quality control. So let's first talk about traceability. The ISO 17025 guide requires traceability. The definition of traceability. Traceability is a property of the result of a measurement or the value of a standard whereby it can be related to the stated references, usually national or international standards, through what's called an unbroken chain of comparisons, all having stated uncertainties. So traceability and quality control. For ISO 17025 laboratories, they need to do essentially three things. One, use traceable calibration standards whenever they are available. Two, if traceable standards are not available, an ISO Guide 34 accredited producer of calibration materials should be selected to assure the best possible standards. And a 17025 laboratory also should verify their calibrations against an independent quality control standard from an ISO Guide 34 accredited supplier. All right, so there's a common theme that's repeated by many of the ISO 17025 accredited labs and labs that are looking for their accreditation for 17025, and it's this. Hey, I don't really have the capability or the adequate resources to produce my own traceable quality control standards. Well, what can I do? Here's the beauty. You can use certified reference materials. So let's spend a little bit of time talking about certified reference materials, what they are, what they entail, and how we can use them in our robust quality control program to get us to the goal. And that goal is to not only get us accredited to 17025, but just as importantly, keep us accredited to 17025. So certified reference materials, or CRMs, okay? Well, what are they? A certified reference material is defined in ISO Guide 34 as a reference material which is characterized by a metrologically valid procedure for one or more of the specified properties, accompanied by a certificate that provides the value of a specified property, its associated uncertainty, and a statement of metrological traceability. CRM producers go through rigorous quality control requirements per ISO Guide 34 in order to become accredited. I make these statements, and a lot of people go, huh? What does that all mean to me? Again, let's break it down a little bit. Talk about the characteristics of the certified reference material. In more layman's terms, it's a standard with known concentrations. They can be called assigned values, they can be called certified values. And those are for specific analytes in a specific product. The standard has a known uncertainty, it has a demonstrated homogeneity, and a demonstrated stability. The assigned values for a certified reference material are traceable to an independent reference. Generally speaking, that independent reference is a standard reference material from NIST. A CRM will come with what's called a certificate of analysis. We'll discuss what that is and what that entails. That certificate analysis includes reference to the characteristics of that certified reference material. Let's talk a little bit about the specifics and the characteristics of a certified reference material. Okay? So when you receive a certified reference material, you're going to get what's called a certificate of analysis along with that. ERRA's CRMs will meet all the requirements of ISO Guide 17043. Okay? And on that, part of that accreditation that ERRA goes through for ISO Guide 17043 means that we have to provide certain information on the certificate of analysis. So as you see here, here's a specific one for our demand standard. It provides the certified value for each of the analytes listed in the standards or the characteristics. It provides an uncertainty. That uncertainty includes the uncertainty in the manufacturing. It includes the uncertainty in the analytical verification, and it includes the uncertainty for what's called the long-term stability of the product. Other information that's required on there is the traceability. So if there's traceability to a NIST SRM, the NIST SRM number will be listed along with the traceability of the analyte to that NIST SRM. Some accredited providers will also supply with that acceptable limits for the verification of that standard. So the next question is, well, what kinds of CRMs are available to me? Okay. There's different types of CRMs that are available that will meet specific requirements of your ISO 17025 accreditation. There's CRMs for calibration standards, for calibrating the equipment that you're going to use to test your standards. Some of them are individual high concentration standards which can be then diluted down to use as your calibration materials. They can also be multi-analyte. So if you're doing testing for ICP mass spec, it might be more viable for you to get these multi-analyte high concentration mixtures, again, which you can then dilute down for your working calibration standards. Or you can get low concentration ready-to-use solutions. The nice thing about that is you're not going to have to do any dilution on those, preferably. So it takes one of the variables out of the equation for you. The second type of CRM that you can use to help you with your quality control program are what are called calibration check standards. They can either be in a simple matrix or in a more complex matrix. They're similar to calibration standards. However, more often than not, these check standards are made from sources which are different from the sources that you're using for your calibration standards, so it provides you with what's called an independent check of that calibration material. You can also get yourself matrix quality control standards. They can either be real or synthetic matrix. They can be with various analytes at various concentrations. Some of them may also even include some of the common interferences you're going to see in your field samples. And these quality control standards are designed to mimic a real-world sample. Okay? Well, that's great and all, but how do I use these CRMs to develop and maintain a quality control system which will help me with my ISO 17025 certification? So let's discuss that. Let's discuss the use of CRMs in what we call a robust quality control program. That robust quality control program will enable your laboratory to not only meet the requirements of 17025 accreditation, but also to maintain that. So there's 4 basic quality control functions in a laboratory. Okay? The first of which is method development. The second is staff training. The third is ongoing performance. And the fourth is corrective action. If you think about these 4 basic functions of your laboratory, meeting these in a robust quality control program will really summarize and will really put together all the requirements of Section 5 of ISO Guide 17025. So let's talk about the first function, which is method development. Okay? There are several areas that need to be addressed in method development. The first is precision. We need to make sure that we have acceptable precision in our method. We'll do that by running a CRM several times in a row to determine the repeatability of a method. So we need to make sure that the method we're using is going to be repeatable enough to meet the uncertainty requirements of our regulatory agency or possibly of our client. Now, repeatability is done by running a standard several times over a period of days or weeks to determine a reproducibility. So we want to make sure that we have repeatability and we have reproducibility to help with the precision of our method development. We also need to make sure that our method is accurate. We need to be able to assure our customers and assure our clients that what we're reporting on our reports is accurate. Okay? This can be done several ways. It can be done by analyzing single blind samples with the use of CRMs or the use of PTs. That's the best way of knowing whether our methods are accurate or not, running something that we don't know the concentration of so that we can report that and we can measure that blind. And in this, it's best to use as much as possible real matrix samples so that we're helping to determine, are we accurate in the matrix that we're analyzing for, whether that be drinking water, whether that be wastewater, whether that be soil or sludge. Also in our method development, we need to determine our detection limit. How low can we accurately measure? So if we're reporting something on a report to a customer, we can then say, hey, we're confident here that we're accurate in the determination and what we're reporting. So we've got to determine a detection limit. Okay? There's a couple of ways of doing that. Simply enough, analyzing blanks, determining where is the difference between my instrument noise and an actual signal that I'm seeing. We also want to determine our reporting limit. How low should we report? Well, we can determine that by using CRMs either in their stock form or diluted forms, depending on the methods that we're trying to develop. We can also use custom-made standards for that, in case that meets our requirements more to our liking. We also have to determine how rugged is that method. Okay? Is it only for drinking water? Is it only for wastewater? Does it carry over between different matrices? Can it handle long-term? Can it handle short-term? So how can we help determine the ruggedness of our method? Simply by the analysis of some QC standards. Okay, that'll help us to determine when we have controlled conditions, when we want to determine the ruggedness in variable conditions. We want to imagine as many variables that could change and test them. Think about the ICP analysis. Think about our sample introduction system, our torch, our injector tip, the power of the instrument, the different parameters that we can run it on, the different matrices that we can go through. We want to be able to test all the variables that we can have in a system to determine how rugged that method is. And most importantly, we want to record the variations and the outcomes of all the variables that we set. So that's what we want to do to develop our method. Okay, so once we've developed the method or a series of methods, what's the next thing we have to do in our quality control system? So the second of the 4 functions is staff training. It's a very, very important basic and a very, very important part of a quality control program, because we can have somebody develop a method and that method could be top-notch, but if our staff isn't trained properly and ongoing training and recording and proof of that training isn't done, then the method that we developed isn't going to be valid. Okay, so some of the things under staff training. When we're hiring new staff or giving them a new method to perform, it's incredibly important to train them. Not only that, but we have to ensure that the training that they're being given is effective. Okay? We can use CRMs as hands-on training samples. So once we go through the process of training our staff, hey, we need to know that the training was effective. Can they really run that method? Can they really run that piece of equipment? Well, how's the best way to do that? We can use a CRM because if we remember, the certificate that comes with that CRM gives us not only the actual certified value of the parameter or parameters that they're testing for, but generally also gives them an acceptance range. So by meeting that acceptance range, we can say, hey, we think that person is trained well enough to be able to run tests by that method. It's really important to make sure that you document the analyst's performance against that assigned value. You want to provide some proof that that staff member is competent to perform the analysis that they're performing. So by having data outputs and some documentation that they're trained, we have that proof of competency. Okay? So once that person is trained, we want to make sure that for an ongoing period of time, we want to make sure that they can regularly run that. So we want to make sure that it's continuing on. And it's important to document that that analyst is still performing with the necessary accuracy and precision. Okay? That can be done by ongoing performance verification. Control charting is a very good way to document ongoing performance of a particular analyst. So if you've got several people who are running the same method, you can do control charting for each one of them and have them control chart the CRMs that they're running to help you determine if there's any kind of trends going on. So with staff training, you want to go through kind of steps. First, you want to gain experience. So in gaining experience, it's a good thing to have your analyst analyze samples under direct supervision to make sure that as the trainer that you're comfortable with the way things are going. Okay? And again, you can supervise them running certified reference materials or also running real-world samples. And it's kind of a good thing to have them do those at the same time, because if they meet the requirements of the CRM, then you know that they're comfortable and competent running some real-world samples. So then, after having under direct supervision, let them go off by themselves. Continue to run CRMs, maybe include an extra QC here or there to make sure that they're comfortable and they're competent. Then we go through with the ongoing performance verification. Okay? Review of standard method QC, the results of the CRMs. Here's where the control charting comes into play. Every once in a while, it's really good to do a single blind QC. Okay, what a single blind QC is, the lab knows that it's a test, but they don't know what the concentrations are. Maybe even do a PT study for each individual analyst. Okay, part of a good, robust quality control program involves analyst certification. If you remember back to our slides at the beginning, that was one of the steps in there for staff certification. Maybe include a double-blind PT. So the lab people that are running the test, they don't know it's a test. Sometimes when they know it's a test or they know it's a proficiency or a PT, they generally tend to treat those samples different, and sometimes you don't want them to. You want them to run the sample as if they thought it was just a regular field sample coming in. That will provide the best test of an analyst's performance. So we've gone through our staff training. We're now comfortable that the people running the tests and the methods are competent to do that. So now let's talk about the third function of your robust quality control program, which is ongoing performance. Okay? So once that method is established, there's still very many variables that can affect the performance of your method. Here's a couple of them. Analysts. Okay? Each analyst on your staff is going to do things slightly different, so they are a variable. The instruments are a variable. The conditions change sometimes on a daily basis, sometimes during the day. Certain instruments are susceptible to changes in not only temperature, but also in changes in the humidity in the lab. Okay? Another variable could be standards and reagents, either made up in the laboratory or purchased. So generally, you hope that you're buying standards from a competent provider so that differences in standards will be minimal. CRMs are a good reason are good to purchase because the variability in standards from lot to lot from a CRM provider are minimal. Okay, but also reagents that are made and purchased can provide variability. The laboratory environment, as we discussed, temperature, humidity, instruments are susceptible to that. Okay, another variable could be sample matrix. The analysis of a wastewater sample could provide variability in things that are different from a drinking water matrix or a surface water matrix. And then you have those random errors that you need to deal with. Okay? So there are a lot of variables that you need to deal with in your ongoing performance. Okay? To help out with that, we need to make sure that we've got routine QC going on. So with respect to that, talking about calibrating, make sure that your calibration standards are fresh. Make sure that they're from a trusted source. Make sure that they're traceable. All this can be accomplished by using CRMs. Let somebody else do the work in getting it certified and traced for you so that you can focus then on the QC that you have going on in your laboratory. You can focus on the analyst. You can focus on the testing so that you're not concerned with, did I make that up right? Okay, also, do continuing calibration verifications. As your run goes on, make sure that the instrument isn't drifting on you. We talked about the variable of environmental conditions. So your continuing calibration, or a CCV, should be made from the same source as your calibration, so that the variable of an independent source doesn't come into play, but it's purely to make sure that your method isn't drifting over time. So that helps check for the short-term drift. You can also do linearity checks. How high can my method go? Am I still linear through a certain concentration range? Use what's called an independent calibration verification, or an ICV. These are made from sources independent from the one that your calibration and your continuing calibration are made from. Okay, certified reference material, again, is a prime way of accomplishing this particular task. The reason you want to do an independent source is if you're calibrating your equipment and you're using the same source to check that, that checks the linearity of your method. It also checks the drift of your method. What it doesn't check is to make sure that the standard is made properly. If there's an issue with the standard, if you're running that same standard against your calibration, it's going to come out in the wash. An independent source will help reveal that. So that's the variable of possibly diluting up your CRM for your analysis. It's generally a good practice to use your independent source or your ICV mid-calibration range, remembering that on a curve, the middle two-thirds of your curve are your most accurate. You'll want to control chart the results of that ICV, most importantly, because that will help you to determine any kind of trends. Am I trending upward? Am I trending downward? Are all my results below the certified value or the mean? Are all my results above? It will help you to see and head off, are there problems coming before that problem gets to a point where corrective action is necessary. So control charting, that's the process of plotting the percent recovery of that certified reference material each time it's analyzed. Ideally, you want to analyze the CRM with every analytical batch, or at least every day that the analysis is performed. If possible, use the same lot of the CRM for your control chart for as long as possible. That will help ensure that any potential variations between CRM lots are not affecting your control chart. And again, if you're consistently using CRMs from the same accredited provider, you shouldn't experience any lot-to-lot variations. So the plotting of the results for control charting, again, will help us to look at trends. It'll help us to try to spearhead if we see something going wrong so that we can work on that. Okay? That brings us to the fourth basic of a robust quality control program, which is corrective action. Okay? Ultimately, things are going to go wrong. Okay? Maybe your staff wasn't trained right. Maybe your method, when developed, was working right, but the changing over time of what you're analyzing, maybe your method's not great anymore. Or maybe you're seeing instruments with your issues with your instrument. There could be a whole lot of things. So inevitably, corrective action is going to come. Okay? So when do we have to do corrective action? We have to do corrective action whenever quality control criteria are not met. Here's a few examples of that. A failed PT sample. That's when we run something blind and the result that we report back to the PT provider is outside of the acceptable ranges. When the calibration linear regression doesn't fit, let's say we're running a 3 or a 5-point curve. It doesn't meet our correlation coefficient. So we need to do some corrective action to find out why. Also, we need to do it when anything is outside of the quality control limits. That's where your control charting comes in. Once we get data points outside of that control chart limit, or if we see trending, we see 5 to 7 data points consistently going up, consistently going down. That's a trigger that corrective action is needed. So what is corrective action? What do I have to do to perform corrective action? The first thing we have to do is a root cause analysis. And that's a whole webinar in itself on how to do root cause analysis. Hopefully you were here a few weeks ago when we did our last webinar on that. But you've got to figure out what went wrong. And root cause analyses are in-depth and they're thorough because you really have to drill down and find out what went wrong. Once we figure out what went wrong, we have to implement corrections. What are we going to do to fix that problem? What are we going to do to fix that root cause? So after we've implemented those corrections, we don't really know if those corrections fix the problem or not. How are we going to do that? We need to test to make sure that those corrections are appropriate. What can we use to test that? CRMs. Because again, you've got a value certified by someone else, so you know what the value is supposed to be. You know what the acceptable limits are supposed to be. Okay? So you can either run CRM with a known concentration, if you want to help that out, or use a proficiency test or a PT, again, so that you don't know the value and that you can truly test whether the corrections that you implemented work. And then we need to make sure that we monitor that those corrections are effective. We want to make sure that running the CRM once, we didn't just get lucky. We want to monitor it as we continue to run that CRM or as we continue to run PTs, make sure that those corrections that we did are effective. Okay. CRMs are incredibly effective when conducting those root cause analyses. Okay? You want to make sure in doing a root cause that you're running stuff using the same conditions that you did when the problem was identified. Make those minor adjustments. Use your CRMs to identify the source of the error. Was it man? Was it machine? Was it materials? Was it the method? Okay? We want to check all of our possible sources. Okay? Could the analyst have been the source? Could it have been the instrument? Could it have been the standards? Using independent sources will help that. Or is our procedure that we generated no longer valid? Okay? So then we go into the implementation or the correction. Once that problem's identified, change has been implemented, you can use your CRMs to help ensure the effectiveness of it. Was that change appropriate? Okay. We make sure that we have new calibration standard to verify. Did we have to retrain the analyst? Give them the CRM to test that they've been retrained properly. Okay. Then the monitoring part comes in to make sure that the change that we made is effective long term. And again, we can have routine use of our CRMs to do that. Continue the control charting so that again we can look at trending to see if anything's going out of control. Okay, so we've talked an awful lot about the requirements of ISO 17025. We went through using CRMs. We talked a lot about using and establishing a robust quality control programs. So in our conclusion today, CRMs can be used to satisfy all of the technical requirements for 17025 accreditation. Think way back to the first 10 or 12 slides where we talked about traceability, we talked about personnel, we talked about staff training, we talked about methods, we talked about validation, verification. In our discussion of the quality control program, the use of CRMs satisfy all those requirements. So you don't have to take your time and go, oh God, what do I have to do to meet all these requirements? Establish that routine and robust quality control program. Use your CRMs for that. In simply doing that and making that a part of your normal day, your normal operations, not only is that going to give you everything you need to accredit yourself, but also to maintain that accreditation. Your CRMs are critical in establishing that, maintaining that. Okay, you can help your lab ensure both reliability of the results and, as importantly, success in your PT performance. Remember that CRMs are certified by an outside source. That will give you added confidence that the standards that you're using and that you're running are made correctly. So that brings us to the end of our webinar today. I know that you guys are very busy and that your time is valuable. I appreciate very much the time you spent with me, and I hope that you learned something with respect to a quality control program, and I hope that you now see how important and how critical CRMs are in not only helping you to establish but also to maintain accreditation in 17025. And I wish you all luck if you're going to get yourself accreditation, and I wish you good success in maintaining that. Thank you for joining me today.